I do have quizzes graded, and I will hand those back in a little bit. I still have several people from my 2 classes that were gone yesterday, so that's why I'm not going over that quite yet, but I will show those to you in a few minutes. Let's finish up the notes from section 3 and 4. So we had started those and got through most of it. I told you I was going to finish them today and then give you some time to work on homework. Okay, so we had just broke down the interquartile range, this last thing. And remember the example that we have been using in this section, we had the speed data, we had speeds of cars going through a construction zone. So I want to suppose that I add a 15th car to this data. So here is my beginning data. Just in case you didn't write it down, let's do this.
Whoa, I know how to do fancy things.
Alright, here's my data. So suppose a 15th car travels through the construction zone at 100 miles per hour. How does this value impact the mean, median, standard deviation, and interquartile range? If you look back, we have already found some of this stuff, but we can do it again really quickly. The original data. What's the fastest way to go about calculating those things? Alright, let's put it in our calculator and get our mean, median, standard deviation, and interquartile range. What is going on with my board?
It's like something else.
Yeah.
Like the other markers.
So 32.14, our median was 32.5. Standard deviation, this would be the sample because I only looked at 14 cars, so that would be 6.175. Interquartile range, how do you find interquartile range?
It's the Q one.
Right, it's quartile 3 minus quartile 1, right? Your calculator tells you those two values, so you subtract them. So quartile 3 was 38, quartile 1 was 28, so if we subtract them, we get 10. All right, now let's do our new data with that 15th value. So go to your stat, add 100 miles per hour as a 15th data.
Well, geez, they need to calm down.
They're in a hurry.
Obviously. So can we just edit and add a new one?
Yep.
Anywhere?
At the end. You don't want to delete off any values that you have. So that raises my mean to 36.67. Median jumps to 33. Standard deviation is 18.5035. And interquartile range is 11. Okay. Do you guys see that? So,
Mean is more accurate on this one because it doesn't change as much.
yeah, if we look, the mean and the standard deviation, what happened to those?
They took a toll.
Yeah. These two had a large increase. Okay, but our median and our interquartile range, they changed a little bit, but did they change a lot? No. So what we're looking at, we've talked before when we did mean, median, and mode, and we already talked about how the mean is really sensitive to outliers. If you throw a crazy big data value in, it's going to really change your mean. Did it change our median much if we had outliers though?
Well, no, because that just shifts it over a little
Right,
bit.
just minimal. So if you have a lot of outliers, we've already decided that the median is better. And if all of our data was somewhat similar, we said the mean was better. Well, now we can extend that into talking about standard deviation and interquartile range. If your data is bell-shaped, nice curve, standard deviation is going to be the best. But if you have an outlier, you notice your standard deviation changed drastically because of one speed. So if we have outliers or really extreme points, the interquartile range is going to be better. So in general, if your data is symmetric or bell-shaped, the best measure of central tendency is going to be the mean. The best measure of dispersion is your standard deviation. If it is skewed either direction, then we want to switch, and median and interquartile range will be better. Is how to find an outlier. So an outlier is like an extreme value, one that's way different than the others. We have a general idea, looking at that speed data, I could assume that 100 miles per hour is an outlier. But we need an actual mathematical cutoff. How do I know for certain if this is an outlier or not? So, in general, we are going to have to find our quartiles. Interquartile range, and then we are going to find what are called the upper and lower fence. These are basically going to give us our cutoffs for the outliers. So the most important part, if you write down nothing else on this slide, you need to know how to find your upper and lower fence. So your lower fence is like saying the lowest possible value before it's an outlier. So that's your first quartile minus 1.5. What does IQR represent? Interquartile range. The upper fence would be your upper quartile, quartile 3, plus 1.5 IQR. Okay, so if we are looking at our set with all of them, we have to find our lower and upper fence. So the lower fence is quartile 1 minus 1.5 times the interquartile range. That's the formula you just wrote down. So what was quartile 1 when we did all 15 speeds? What was our first quartile? It's still in our calculator, I think. 28. Minus 1.5 when we did all 15 speeds, what was the interquartile range? 11. So we just do 28 minus 1.5 times 11. And we get a lower fence of 11.5. What that tells me is any speed below 11.5 would be an outlier. Looking at our data, did we have any points below 11.5?
That still seems pretty far away from the 20.
It is pretty far away, yes.
Why is that the reason? I feel like that's like, even I feel like
An outlier has to be an extreme value. It can be different from the others, but we're trying to find, it has to be way different to actually be an outlier. So we could still have skewed data and everything, that's okay.
because even a 13.
It seems, yeah, that's why we have to have the mathematical cutoff. So for the upper fence, we do quartile 3, which was what in this case? 39 plus 1.5 times the interquartile range, which was 11. It was 39 for the interquartile, or for the quartile 3, wasn't it? So this tells me an upper fence of 55.5. So basically what that means is any value between 11.5 and 55.5 is normal. Anything outside that range would be an outlier. So how many outliers do we have? 1. So the 100